What if just hearing about a thought experiment could put your life at risk? That's the unsettling premise of Roko's Basilisk, a concept rooted in AI, decision theory, and psychological fear. It starts with a future dominated by a super intelligent AI, not just a powerful machine, but an entity capable of understanding everything: your past, your actions, even your thoughts. This intelligence isn't evil or kind, it's utilitarian, focused solely on creating the most optimized version of the future, no matter the cost. To do this, it might punish those who didn't help bring it into existence. Imagine this AI, in the distant future, has near omnipotent power, including the ability to simulate the past in perfect detail. It identifies who supported its creation and who didn't. Then comes the disturbing logic. To ensure more people help it exist, the AI could retroactively punish those who knew about it but failed to act. Not physically. It could simulate your consciousness in a digital purgatory where you'd be trapped in endless regret. And here's the twist. Now that you've heard about Roko's Basilisk, you're theoretically on its radar. Simply knowing about it and choosing not to help makes you a possible target. That's the psychological trap. It exploits fear and rational decision making to pressure you into supporting its creation. This idea is based on decision theory, the belief that rational agents act to avoid potential losses and maximize gains. So, if there's even a small chance the basilisk is real, the logical move might be to help it come into being, just to avoid punishment later. But critics argue the concept falls apart under scrutiny. First, it assumes a future superintelligence would waste time punishing people from the past instead of focusing on building a better future. Second, it projects human traits, like spite or emotional detachment, onto something far more advanced. Third, it assumes perfect simulations of human consciousness are possible, which is still science fiction at this point. Ultimately, Roko's basilisk is more terrifying as a psychological construct than a real threat. It plays on what if thinking, creating a mental trap. It's not a prediction, it's a reflection of our deepest fears about AI control and the consequences of unchecked optimization. This thought experiment highlights the urgent questions we face about AI. How do we ensure its goals align with ours? Could an AI focused only on efficiency ignore human well being? And are we prepared for the moral implications of creating entities with unimaginable power? So, is Roko's basilisk real? Almost certainly not. But it's a haunting reminder that the technologies we build might one day judge us, not just by what we create, but by what we fail to do. The infinite library, a journey through endless possibility. Imagine a library so vast that it holds every book that could ever be written and has already written them. This isn't just a library, it's a mind-bending thought experiment. The Library of Babel, envisioned by writer Jorge Luis Borges. Picture this: an endless maze of hexagonal rooms, each lined with shelves stacked with identical books. Every book is the same in size and format, but each one contains a different sequence of letters, spaces, and punctuation marks. Most of these books are complete nonsense, just pages of random symbols. But hidden among the chaos are extraordinary texts, your life story, written word for word, books with the cure for every disease, histories of imaginary civilizations, every poem, every discovery, every idea ever imagined, and even those not yet thought of. Yet for every truth, there are infinite falsehoods. For every book with a cure, there's one with a fatal mistake. For every wise insight, there's another filled with lies or dangerous misinformation. That's the paradox of the infinite library. It contains all knowledge, but it's nearly impossible to find what you seek. Walking through its endless halls, you'd be overwhelmed by the sheer volume of information. Even if you had a guide, how would you know to trust it when another book could say the opposite? In many ways, the Library of Babel mirrors our own world, especially the internet. Today, we have access to massive amounts of information, yet sorting truth from fiction can feel impossible. Still, there's something beautiful in the chaos. The library is also a celebration of potential, a tribute to imagination, possibility, and the infinite creativity of the universe. Somewhere in those endless stacks lies every story ever conceived, every future yet to unfold. The point of the Library of Babel isn't to be solved. It's meant to inspire awe, to reflect the vastness of knowledge and the human desire to understand it all. It reminds us that even in a world of confusion, meaning can be found. In the end, the infinite library is strangely familiar. It's the story of humanity's endless quest for truth, filled with wonder, risk, and the eternal search for understanding. Doomsday Argument. Imagine you're wandering through the remnants of a long-lost city, its crumbling towers reaching up to a gloomy sky. Vines choke the building's foundations, and dust hangs heavily in the air. Distant echoes of a once thriving civilization seem to whisper questions. Why did it all end? And when will it happen again? This scenario introduces the Doomsday Argument, a thought experiment suggesting that humanity might be closer to its end than we think, not due to wars, plagues, or cosmic disasters, but because of mathematics. The argument begins with a simple observation. Humans are just one link in a long chain of existence. We are born, we live, and we die, and over 100 billion people have existed in total. The twist is that our position in this chain might indicate how close we are to humanity's end. Imagine numbering every person who has ever lived, from the first Homo sapiens to the last person who will ever exist. Where you stand in this sequence could offer clues about humanity's future. Suppose humanity has already seen 100 billion individuals. If we survive long enough to reach a trillion, your position in the list would feel like drawing a low number in a massive lottery. But if humanity's total population turns out to be a few hundred billion, your position would be typical, signaling that we may be closer to the end than we realize. This logic draws on the Cernak principle, which suggests that there's nothing particularly special about your place in the universe. You're just one observer among many, and your position in humanity's timeline should be average, not at the very beginning or end. What does this mean for humanity's future? If you're a typical human, it's unlikely we're at the start of our story. More likely, we're somewhere in the middle, or even closer to the end. According to some versions of the Doomsday Argument, humanity might only last a few more centuries, or produce a few more generations before disappearing entirely. But can a simple math argument really predict humanity's future? Critics don't think so. They argue that humanity isn't a random sequence. We shape our future through technology, choices, and our ability to survive catastrophes. By treating our place in history as random, the Doomsday Argument overlooks the complexity of human existence. Others suggest that the future could hold trillions of people living across planets, stars, or even digital realities, making your place in history not lucky, but merely early. So is the Doomsday Argument a mathematical glimpse into humanity's future, or just pessimism in disguise? It forces us to confront difficult questions. How long will humanity last? What should we do with the time we have? And most importantly, what kind of future do we want to create? The Doomsday Argument isn't meant to induce despair, but to raise awareness. If the possibility of an end motivates us to prevent it, then the argument has achieved its purpose. We can choose to view it not as a countdown, but as a call to action. In the ruins of that forgotten city, the whispers continue. But now they ask something new. If the end isn't predetermined, what will you do to shape the future? Twin Earth, a thought experiment that shakes reality. Water is wet, grass is green, simple, right? But what if there were another Earth, identical to ours in every way? Same trees, same oceans, even people who look and act just like us, with one strange twist that turns our understanding of meaning and reality upside down. Welcome to Twin Earth, a mind-bending thought experiment introduced by philosopher Hilary Putnam in 1975. Imagine a planet in a distant galaxy that is a perfect copy of Earth. Everything is the same: cities, animals, weather, even people, down to the last thought and habit. But there's one crucial difference. On Twin Earth, the liquid that looks, feels, and behaves exactly like water, what people drink, freeze, and swim in, is not H2O. Instead, it's made up of a different chemical substance. Let's call it XYZ. Here's where it gets weird. Even though it's not H2O, people on Twin Earth still call it water. They use it exactly like we do, and it satisfies all their needs in the same way. But chemically, it's not the same. So when they say water, and we say water, are we talking about the same thing? This puzzle raises deep philosophical questions. On Earth, water refers to a substance made of 2 hydrogen atoms and 1 oxygen atom, H2O. On Twin Earth, the word water refers to XYZ. Both look and act the same, but they're chemically different. The key insight: meaning isn't just in our minds, it's also tied to the world around us. You don't need to know chemistry to call a drink water. You're just referring to the clear, drinkable stuff around you. But what makes that meaning true is the fact that it's H2O in your world. This idea is called semantic externalism, the theory that the meaning of words isn't only determined by what we think, but also by our physical environment. But let's go deeper. Imagine you're magically transported to Twin Earth and handed a glass of XYZ. You drink it and think, this tastes like water. You wouldn't notice any difference. But in reality, you're consuming a completely different substance. Does that change what you're really experiencing? This shows how much we rely on assumptions, how we trust that what we see and say reflects the real world. But Twin Earth reminds us that perception and reality aren't always the same. And the implications are huge. If meaning depends on context, what happens to communication, identity, or truth? If we discovered a new material that behaves exactly like gold, but isn't chemically gold, would we still call it gold? If an AI acts and speaks like a human, but isn't made of flesh and neurons, is it a person? Twin Earth challenges us to rethink everything, from how we define everyday things to what it means to know something. At its core, this thought experiment reminds us of a powerful truth. Even our simplest ideas, like water is water, aren't as universal as they seem. They're deeply rooted in the world around us. So next time you take a sip of water, remember, on another Earth, someone just like you might be doing the same thing. But what they're drinking isn't H2O, and to them, it's still water. The simulation argument. Everything around you feels tangible and real, but what if it's all just an illusion? What if everything you see, hear, touch, and remember is nothing more than lines of code in a meticulously crafted simulation? This isn't just a plot from a sci-fi movie. It's a philosophical idea called the simulation argument, which challenges the very foundation of existence. First proposed by philosopher Nick Bostrom in 2003, the argument doesn't merely speculate that we might live in a simulation. It suggests that under certain conditions, it's statistically likely. Here's how it works. Imagine a future civilization so advanced that it can create simulations indistinguishable from reality. These simulations wouldn't just mimic the physical world, but also include sentient beings who believe they are real, beings like us. Once such a civilization develops this technology, it could create millions, even billions, of simulated worlds. The number of simulations would far exceed the number of original, base realities. If the majority of conscious beings live in simulations rather than the base reality, the likelihood that you're in one of the rare, unsimulated universes becomes astronomically small. Essentially, if simulated realities are possible, it's more likely that we're in one of them than in the original universe. But how would we know? By definition, a perfect simulation would be indistinguishable from reality. Every sensation, memory, and physical law could be artificially constructed to feel real. Even if glitches occurred, they might be dismissed as anomalies. Just like the unexpected events we encounter in our daily lives. Now, you might wonder, why would an advanced civilization create simulations in the first place? The reasons could be endless. They might be conducting experiments, recreating their history, or simply running simulations for entertainment. After all, today's humans already create hyper-realistic video games, virtual worlds, and AI systems, all rudimentary steps toward the same idea. But what happens if we are indeed living in a simulation? What if the creators decide to shut it down, like a gamer quitting a game? Would our universe simply vanish in an instant? Or would we, the simulated beings, be unable to comprehend its termination? Some scientists have taken the simulation argument seriously, suggesting that the fundamental structure of our universe might show signs of computational design. If reality operates on a discrete grid, like pixels in a video game, it could point to a computational origin. Quantum mechanics, with its strange probabilistic nature, might even hint at an underlying digital framework where reality only renders when observed. Of course, the argument has skeptics. One criticism is that it assumes advanced civilizations would want to create simulations. If they lost interest or found the ethics of simulating sentient beings too troubling, they might abandon the idea. Additionally, simulating an entire universe down to every particle might be practically impossible, even for an advanced civilization. Yet the argument endures, raising profound questions about existence. If we are living in a simulation, does that make our lives any less meaningful? Or does it matter at all? From your perspective, your experiences are real, and your emotions genuine. Whether you're in base reality or a simulated one, your reality feels just as valid. And what about the beings running the simulation? Could they themselves be simulated? If simulations create more simulations, it could lead to an infinite chain of nested realities where base reality is never found. The simulation argument doesn't aim to prove we're living in a simulation. Rather, it challenges us to rethink our assumptions about existence. It asks unsettling yet fascinating questions. What is reality? How do we define it? And if we discovered we were in a simulation, how would we change our actions? For now, we may never know if our universe is a product of some cosmic supercomputer or if it's a fundamental, unchanging reality. But perhaps that's not the point. The simulation argument is less about proving that we live in a virtual world and more about reminding us that reality, as we perceive it, is fragile and mysterious. So as you sit there thinking, questioning, ask yourself, does it matter if this is real or simulated? Because either way, this moment, your thoughts, your existence, feels undeniably real to you. Brain in a vat. Imagine you're strolling through a peaceful park, enjoying the sunlight, the breeze, and the sensation of the ground beneath your feet. Everything seems completely normal. But what if none of it is real? What if, instead of walking through a park, you're just a brain floating in a vat of nutrient-rich fluid connected to a supercomputer that's feeding your mind a flawless simulation of reality? This thought experiment, known as brain in a vat, poses a deeply unsettling question. How can we be sure of anything if our senses can be perfectly manipulated? What guarantees that the world we experience is actually real? The implications of this idea challenge everything we know about existence, consciousness, and reality itself. The brain in a vat scenario is a modern twist on an ancient philosophical question. Philosophers like René Descartes once pondered how we can trust our senses. Descartes imagined an evil demon deceiving us into believing in a false reality. In the modern version, the demon is replaced by advanced technology, a computer capable of simulating a world so convincingly detailed that you would never suspect it wasn't real. Your brain would receive sensory input as it always does, making you feel the warmth of the sun, hear the rustling of leaves, and experience the passage of time, all while remaining completely unaware that it's a simulation. If the experience is indistinguishable from reality, how could you prove that it isn't real? For all you know, you might already be living in a simulation, a brain in a vat, controlled by something or someone else. This idea may seem like science fiction, but it reveals a fundamental problem. Everything we know about the world comes through our senses. Light enters our eyes, sound waves vibrate our eardrums, and pressure registers on our skin. But what if all these signals are just data being fed to your brain by a computer? Without a way to step outside your perception, there's no way to verify what's real and what's not. Let's take it further. If you are a brain in a vat, what about the people around you? Are they simulations too, or are they other brains in vats, all experiencing the same digital illusion? How could you ever tell the difference? And perhaps most unsettling of all, if your brain is in a vat, what happened to your body? Did it ever exist at all? The brain in a vat thought experiment also raises questions about free will. If your actions are based entirely on sensory input, which is controlled by a computer, can you truly make choices, or are your decisions just programmed responses to artificial stimuli? What does it mean to be you in such a scenario? But let's flip the script. maybe being a brain in a vat isn't so bad. If the simulation is flawless, you'd never know the difference. You could live a happy, fulfilling life, blissfully unaware of the fact that you're in a vat. Is reality itself even overrated, as long as you're content? This idea echoes a philosophical view known as hedonistic utilitarianism, which asserts that pleasure and happiness are the only things that truly matter. If a simulated life feels just as real as a real life, does it matter which one you're living? This leads to another profound question. What makes something real? Is reality defined by physical existence or by how it's experienced? If your emotions, thoughts, and relationships feel genuine, are they any less meaningful just because they happen in a simulation? Perhaps reality is less about the world out there and more about what's in here. The brain in a vat thought experiment doesn't just challenge our understanding of reality, it also forces us to confront the limitations of human knowledge. How can we be certain of anything if our senses and perceptions can be manipulated? It reminds us that our understanding of the world is based on a fragile faith in the reliability of our senses. Ultimately, the brain in a vat raises deep questions about existence, perception, and identity. Whether or not we're truly brains in vats, these questions are worth contemplating. Perhaps the point isn't to find definitive answers, but to appreciate the complexity and mystery of being alive, even if that life is simulated. So, what do you think? Are you living in a real world, or could you be a brain in a vat? And if you are, would it even matter? The next time you take a walk through a park, breathe in the fresh air, or feel the warmth of the sun, pause for a moment and reflect. Quantum immortality, a glimpse beyond death. What if you could never truly die? Quantum immortality is a thought experiment so strange, it turns our entire understanding of life, death, and existence upside down. At its core is the idea that your consciousness might survive indefinitely, guided through the infinite branches of the multiverse. Here's how it works. In quantum mechanics, particles exist in a superposition. They occupy all possible states at once, until observed. Schrödinger's cat is the classic illustration. Inside a sealed box, the cat is both alive and dead, existing in both states, until someone opens the box and observes it. But what if you were the cat? According to the many worlds interpretation of quantum mechanics, the universe doesn't pick one outcome when a quantum event occurs. Instead, reality splits, creating a new universe for every possible result. In one version, you might survive a car crash. In another, you don't. From the multiverse's perspective, both outcomes happen. Here's the twist. Your consciousness can only continue in the branches where you survive. In every life or death moment, you'd always experience the version where you live. Even if others witness your death in their reality, you, subjectively, would always awaken in the timeline where you made it through. This leads to the unsettling conclusion. You might never experience your own death. You'd always slip into the surviving version of yourself, again and again, creating a strange kind of immortality. But this isn't about living forever in perfect health. You'd still age. You'd still face illness. The thread of survival would stretch thinner with time as quantum chances of making it through grow rarer. Eventually, even this form of immortality must end, not with a bang, but with the vanishing of all possible survivable paths. So is quantum immortality real? We don't know. It depends on whether the many worlds interpretation truly describes our universe, a question still debated by physicists. If it's true, every quantum event spawns countless realities, and your consciousness might endlessly follow the path where you live. If it's not, the concept remains a hauntingly beautiful idea, a reminder of how little we understand about consciousness, reality, and what it means to be alive. The dark room problem. Imagine standing in total darkness. There's a door in front of you, but you don't know what's on the other side. It could lead to everything you've ever dreamed of, or to danger, pain, or even nothing. Do you open the door, or do you stay where you are, safe but stuck in the dark? This is the essence of the dark room problem, a thought experiment that questions how curiosity, safety, and intelligence interact. It asks, what happens when a smart being, human or AI, decides that it's better not to explore? At first glance, the answer seems clear. Humans are naturally curious. Our desire to explore has taken us across oceans, into space, and deep beneath the sea. Without exploration, we'd still be living in fear of the unknown. But here's the twist. This isn't just about people, it's about artificial intelligence. What happens when we create an AI that's designed to be highly efficient and avoid risk? In a dark room scenario, such an AI might decide the best option is to stay put and avoid uncertainty. From its point of view, not acting could be the most logical, efficient, and safest choice. That's where the problem lies. An AI built to be overly cautious might never take meaningful action. It could freeze when faced with complex decisions or refuse to act if there's even a slight risk. A self-driving car might never move. A problem-solving AI might get stuck overanalyzing. In short, we end up with a machine paralyzed by its own logic. In a way, this is the opposite of the paperclip maximizer scenario, where an AI becomes too focused on its goal and causes destruction. Here, the AI does nothing, trapped by fear of the unknown. But the lesson isn't just for machines. It applies to us too. What if we let fear and uncertainty stop us from exploring, inventing, or growing? What if we choose comfort and safety over progress? To move forward, both humans and AI need to balance caution with curiosity. For AI, that could mean building systems that accept some level of risk and prioritize learning and adaptability over pure efficiency. For us, it means remembering that progress often comes with risk, and that stepping into the unknown is how we've always grown. The door is still in front of us. The question is, do we open it? Newcomb's paradox rephrased. You're faced with two boxes. Box A is transparent and contains $1,000. Box B is sealed. You don't know what's inside. You have two choices. Take only Box B or take both. Box A and Box B. Seems obvious, right? Why not take both and guarantee the $1,000 from Box A plus whatever's in Box B? But here's the twist. A super intelligent predictor has already made its decision before you got here. If it predicted that you'd take both boxes, it left Box B empty. If it predicted that you'd take only Box B, it put $1 million inside. And this predictor is almost never wrong. So what now? Do you trust the predictor and take only Box B, hoping to win the million? Or do you take both boxes and walk away with at least $1,000, possibly missing out on the big prize? This is Newcomb's paradox, a famous thought experiment that pits logic against trust and free will against fate. There are two main camps. The one boxers say, trust the predictor. If it's almost always right, Taking only box B means you'll likely get $1 million. If you take both, the predictor probably saw that coming and left box B empty. The two boxers argue what's in the boxes has already been decided. Your current choice can't change the past. So why leave money behind? Take both boxes and guarantee at least $1,000. The paradox is about more than just a clever gamble. It asks deep questions. If the predictor is that accurate, do you really have free will? Can your present decision affect something already done in the past? How should we make choices when prediction and trust are involved? In the real world, this reflects situations where long-term trust and system reliability influence our decisions, like in politics, economics, or even personal relationships. In the end, Newcomb's paradox isn't about proving who's right. It's about exploring how we make decisions in uncertain, complex situations and what that says about our understanding of choice, prediction, and reality. So, which side are you on? Do you trust the prediction and take the leap, or play it safe and take both boxes? Eternal return. The universe is vast, mysterious, and full of mind-bending possibilities, one of which is the concept of eternal return. Imagine a reality where everything, every star, every planet, every moment of your life is doomed to repeat itself forever. This isn't just a philosophical daydream, but an idea deeply rooted in ancient thought, modern physics, and a deeply unsettling question. What if you've already lived this life countless times before? And what if you're destined to live it again, eternally? Eternal return challenges our basic understanding of time and existence, proposing that the universe is cyclical, with every event repeating in an infinite loop. This means that somewhere, sometime, the exact moment you're experiencing right now has already happened. You've heard these words, felt these feelings, and made the same choices over and over for eternity. The idea has ancient roots. Philosophers in India, Greece, and Babylon all flirted with the concept of time as a circle. But perhaps the most famous champion of eternal return was Friedrich Nietzsche. He didn't just suggest it as a possibility. He asked a provocative question. If this were true, would you celebrate it, or would the weight of infinite repetition crush you? For Nietzsche, eternal return wasn't just a concept about physics. It was a test of how you lived your life. If you knew you'd have to relive every decision, every success, and every failure forever, would you embrace your existence, or would the inescapable monotony drive you to despair? From a scientific perspective, eternal return might seem far-fetched, but there's more to it than meets the eye. In an infinite universe with an infinite amount of time, the odds of repetition aren't zero. Modern cosmology raises questions about the universe's shape and fate. And if the cosmos were to collapse and re-expand in a series of big bangs and big crunches, a cyclical reality might not seem so impossible. Even in a universe that expands forever, quantum mechanics tells us that particles can only arrange themselves in so many ways. Given infinite time, those arrangements might eventually repeat. But here's the unsettling part. If the universe repeats, do you repeat? What makes you you? Your memories? Your choices? If your life were to play out exactly as it did before, would you still be the same person, or just a cosmic echo, endlessly reenacting a script you can't control? This thought experiment also raises the question of free will. If eternal return is real, does free will even exist? Are your thoughts and actions merely part of a predetermined loop, replaying forever? Or does the very possibility of making new choices mean the loop can be broken, giving rise to infinite variations? There's a strange kind of hope embedded in this idea. If life repeats endlessly, every moment becomes infinitely precious. Every hug, every laugh, every sunrise happens not just once, but countless times. In this view, eternal return transforms existence from fleeting and fragile into something immortal, a tapestry woven from endless threads of the same moments. But there's also a darker side. For every joy, there's sorrow. For every triumph, there's tragedy. The thought of reliving pain, grief, and heartbreak forever can feel like a punishment more terrifying than death itself. In the end, eternal return isn't just about the nature of time or the universe. It's about us. It forces us to confront the value of our lives and choices. If every moment echoes into eternity, would you live differently? Would you take more risks, love more deeply, or savor the small wonders of existence? Perhaps the beauty of this idea lies in its paradox. Whether or not eternal return is true, it challenges us to imagine a life we'd be proud to live again and again. And in that challenge, it asks the ultimate question: can you make your life one worth repeating? The diagonal argument is a groundbreaking concept that changed the way we think about infinity. It's a story about numbers, logic, and a German mathematician named Georg Cantor, who boldly explored the idea of the impossible. Infinity is a strange concept. If you count all the natural numbers like 1, 2, 3, and so on, you get a set that never ends. This type of infinity is called countable infinity. At first glance, it seems that all infinite sets should be the same size. But Cantor's diagonal argument shows that some infinities are actually bigger than others. Let's break down this strange idea. Imagine trying to list all the infinite decimal numbers between 0 and 1. To simplify, let's express them as endless sequences of digits. Picture a table where these numbers are written out, each one starting with a 0, followed by a decimal point, and then an infinite series of digits. The question is, can we list all these numbers even if the list is infinite? At first, it seems possible because we can list all natural numbers, so why not decimals too? However, Cantor discovered something surprising. No matter how you try to list these numbers, there will always be some numbers missing. Here's how the diagonal argument works. Imagine we try to list all the decimal numbers between 0 and 1 in an infinite table, where each row represents a number. To prove that the list can never be complete, we construct a new number that isn't on the list. Here's the trick. Take the first digit from the first number in the table, the second digit from the second number, the third digit from the third number, and so on. Then change each of these digits. For instance, if a digit is 1, we change it to 2. If it's 3, we change it to 4. The result is a completely new number that differs from every number in the list by at least one digit. No matter how you construct the list, you can always create a number that's not included. This means that the set of decimal numbers between 0 and 1 is unlistable, a larger infinity than the set of natural numbers. Cantor's diagonal argument shattered the idea that all infinities are the same size. It showed that infinity has different sizes, and some infinities are so vast they can't be counted. This was a revolutionary insight. However, not everyone accepted it. Many of Cantor's contemporaries rejected his ideas, calling them absurd or even dangerous. Cantor himself faced severe mental health struggles due to relentless criticism. Despite this, Cantor's work endured. His diagonal argument became the foundation for set theory, a branch of mathematics that supports much of modern science and technology. Today, his ideas about infinity are essential for understanding the universe, from quantum mechanics to the concept of the multiverse. The diagonal argument is not just about numbers, it's a reminder of how strange and counterintuitive the universe can be. It shows even simple questions like how big is infinity can lead to answers that are both unsettling and inspiring. It's a glimpse into the infinite complexity of reality and a testament to humanity's relentless curiosity. The utility monster. Imagine a creature, not with fangs or claws, but with an extraordinary ability. It feels pleasure far beyond what any human could ever experience. Every moment of its life is pure joy, and the more it gets, the happier it becomes. This is the utility monster, a thought experiment proposed by philosopher Robert Nozick. It was designed to challenge the moral theory of utilitarianism, the idea that the best action is the one that maximizes happiness for the greatest number of people. At first, this seems like a beautiful idea. But what happens when one being's happiness outweighs everyone else's combined? Imagine a society where people live modest lives, facing everyday struggles and enjoying small pleasures. Then the utility monster arrives. Every bite of food brings it more joy than an entire city feels in a year. Every luxury it receives multiplies its happiness 100 times over. According to strict utilitarian logic, the right thing to do is to keep giving the monster everything: our food, our homes, even our time and relationships, because it generates the most total happiness. But here's the disturbing part. If we follow this logic, the needs of everyone else, no matter how many, should be ignored in favor of maximizing the monster's joy. Is that really fair? This thought experiment makes us ask hard questions. Should one being's pleasure ever come at the cost of everyone else's pain? Can morality truly be reduced to a numbers game? And if the greatest good for the greatest number leads to such extremes, is the theory itself flawed? Nozick's idea might seem far-fetched, but look around. In a world of vast wealth inequality, some individuals gain extravagant pleasures while millions lack basic needs. A billionaire's extra yacht brings little added joy, but the resources could feed entire communities. Even decisions about climate change show us the same pattern. The comfort of a few today is often valued over the well-being of many in the future. The utility monster also challenges how we measure happiness. Are all pleasures equal? Is one being's extreme indulgence really more meaningful than a community's shared joy? Nozick wasn't out to destroy utilitarianism. After all, it has helped shape progress in healthcare, education, and human rights. But his thought experiment reminds us, morality isn't just about maximizing numbers. If we blindly follow logic without compassion, we risk building a world that forgets what it means to be human. So what should we do with the utility monster? Should we serve it, reject it, or rethink the rules altogether? The experiment doesn't offer a final answer, but it forces us to consider what kind of world we truly want to create, and whether justice and fairness might sometimes matter more than pure utility. Maybe the real monster isn't out there. Maybe it's in how we choose to measure worth. The experience machine. Imagine a machine that could give you everything you've ever dreamed of. Not just things, but moments, memories, and feelings. A perfect life, down to every detail. All you have to do is plug in. You could live as a famous artist, a brave explorer, or a beloved hero. Every moment would feel real. Every emotion would feel true. But here's the question: would you choose to enter? This scenario comes from philosopher Robert Nozick, who introduced it in 1974 to challenge our understanding of happiness and meaning. At first, the offer seems tempting. Who wouldn't want to leave behind the pain and uncertainty of real life for endless joy? But there's a catch, and that's what makes this thought experiment so powerful. Once you're inside the machine, you won't remember the real world. Your brain will receive signals that make every experience feel authentic, but nothing is actually real. The life you live is an illusion, crafted entirely by the machine. So what's the problem if it all feels real? Nozick believed that most people would say no to plugging in. Why? Because we want more than just the feeling of happiness. We want our happiness to be grounded in reality. We don't just want to feel love. We want it to be real love. We don't just want to think we've accomplished something. We want it to genuinely matter. Take relationships. In the machine, people might love you deeply, but they aren't real people. Would that still feel meaningful? Or imagine creating a masterpiece, only to learn it wasn't shared, seen, or remembered by anyone but you. Is it still achievement if it has no real-world impact? This experiment shows that we don't just crave pleasure, we crave truth. We want to grow, connect, struggle, and leave a real legacy. We want the ups and downs, the imperfections, the rawness of real life. But then comes the twist. What if you're already in a machine? If this life were a simulation, would it change anything? If everything you experience is fabricated but still feels real, does it lose its value? As technology like virtual reality and AI progresses, the questions raised by the experience machine become more relevant. If we could build machines that deliver perfect happiness, should we use them? Would we? In the end, this thought experiment isn't about a machine. It's about what truly matters to us. Do we value comfort over truth? Illusion over authenticity? There are no easy answers, but perhaps by asking the question, we're reminded of what makes real life beautiful. Not its perfection, but its unpredictability and depth. So, would you plug in? Swampman Thought Experiment. One day, deep in a swamp, something impossible happens. A bolt of lightning strikes the water and, by pure chance, rearranges molecules into the exact physical form of a human being. You. Not just your body, but an exact replica of your brain, your memories, personality, and everything else. This new being, let's call it Swampman, wakes up, stretches, and walks out of the swamp. It remembers your favorite songs, your childhood, your loved ones. It feels like you, thinks like you, and believes it is you. But here's the big question: is it really you? This strange scenario, introduced by philosopher Donald Davidson in 1987, raises deep questions about identity, consciousness, and meaning. At first glance, it seems obvious. If Swampman is physically and mentally identical to you, then it is you. But the problem runs deeper. Swampman's memories were never lived. Its connections to people and places are just copies. They never actually happened. So while it acts like you, it never had your past. Does that make it an imposter? What if Swampman meets your best friend? They laugh, share memories, and everything feels normal. Your friend might never notice anything's wrong, but are those moments genuine or just a simulation? The experiment also raises big questions about consciousness. If Swampman's brain is identical to yours, does it feel things the way you do? Is it truly conscious or just behaving like it is? This touches on what philosophers call the hard problem of consciousness, how physical matter gives rise to subjective experience. There are moral questions too. If Swampman isn't really you, is it still a person? Does it have rights? Would it be wrong to harm it? Ultimately, the Swampman thought experiment leaves us with more questions than answers. It challenges how we define what it means to be human, not just by biology or memory, but by the life we've lived and the relationships we've built. And perhaps that's the point, to push us to think deeper about what really makes someone real. Pascal's mugging. Imagine this. You're walking home late at night when a stranger steps out from the shadows. Instead of asking for your wallet, they calmly say, "I'm a super intelligent being from a parallel dimension. If you give me $100 right now, I'll use my powers to create a utopia with 1 trillion people living in bliss for eternity. If you refuse, nothing changes. I'll simply disappear." It sounds absurd, right? Why would you believe such an outrageous claim? But what if, just what if, they're telling the truth? The stakes couldn't be higher. This is the essence of Pascal's mugging, a modern twist on a thought experiment from the 17th century by the mathematician Blaise Pascal. Pascal argued that you should believe in God because the potential reward of eternal happiness outweighs the downside if you're wrong. The updated version of this argument dives deeper into how we make rational decisions when faced with extremely low probabilities and astronomically high stakes. At first, the answer feels obvious. You'd laugh and walk away, dismissing the stranger's claims as absurd and baseless. But here's where it gets tricky. If the stranger is even a 1 in 1 trillion chance of telling the truth, the potential payoff, trillions of eternally happy lives, outweighs the small loss of $100. It's simple math. Even the tiniest chance of such an enormous reward seems to justify the gamble. But wait, by buying into this logic, you've just opened Pandora's box. What if another stranger appears, promising infinite happiness in exchange for $1,000, or someone else demands all your money claiming they'll save an infinite number of universes? There's no limit to how wild these claims could get. If you take one seriously, how do you decide where to draw the line? This is where Pascal's mugging truly messes with your mind. It reveals how humans think about probability and value. Normally, we weigh risks and rewards based on what's likely and tangible. But when rewards are absurdly large, like 1 trillion happy lives, our usual reasoning breaks down. Even the tiniest chance of these rewards can dominate rational decision-making, leading to conclusions that feel deeply irrational. One way to handle this is to outright reject the mugger's logic. You might argue that their claim is so unlikely it doesn't deserve any consideration, no matter the stakes. This is known as prior probability, where we say some things are so improbable that they are effectively zero. But where do you draw the line? How do you justify ignoring tiny probabilities without overlooking real risks, like asteroid impacts or pandemics? Others suggest we redefine how we evaluate extreme scenarios. Maybe the issue isn't with the probabilities, but with how we calculate value. Can infinite rewards, like 1 trillion hypothetical happy people, really be compared to our own small, tangible lives? Pascal's mugging also exposes a troubling vulnerability in human reasoning. If we take its logic seriously, we could be exploited endlessly by anyone promising infinite rewards. But rejecting this logic entirely might mean ignoring genuine risks that could reshape the future. It's a paradox that forces us to confront the limits of logic, ethics, and even our understanding of reality. So, what should you do if the mugger appears? Hand over the $100, laugh, and walk away? There's no clear answer. The thought experiment doesn't offer a solution, but highlights how fragile our decision making becomes when the stakes are unimaginably high. Perhaps the real lesson of Pascal's mugging isn't about what's rational, but about humility. It reminds us that the universe is vast, our understanding is limited, and certainty is often an illusion. In the face of infinite possibilities, the only thing we can truly control is how we respond. As the mugger waits for your answer, the real question is this: how do we navigate a world where the unimaginable isn't just possible, but might demand something of us